Today we are talking about optimization. And here's our example problem. We are designing an open box that has a square base and surface area of 108 square inches. Now we need to find the dimensions that will give us a box with a maximum volume. So I'm going to start just with a little picture of a box. And we know we need a square base, which means that this dimension should be equal to this dimension. And then we'll have a third dimension, the height, which I'm going to call y. So now that I have my picture, I'm going to take a look at what we want to maximize. We're maximizing volume. So I'm going to write an equation for volume. Volume is equal to length times width times height. So in this case, the way that I label the dimensions, it would be x times y, or just x squared y. And this is what we call our primary equation. Because it's the equation of the dimension we want to, or the quantity that we want to maximize. The problem is that this equation has two variables. We've got an x and a y. We would like to write this in a single variable. So we use whatever additional information we have to establish a relationship between x and y. And we know that the surface area is 108 square inches. So we're going to write an equation for the surface area. We know that surface area is equal to the area of all the sides added up. Now we have four sides. That would be x times y. Four sides with an area of x times y. And then the bottom, the base of our box, would have an area of x squared. And it's an open box, so there's no top. Now this is equal to 108 square inches. And this is our secondary equation. So what we're going to do is take this system of equations and rewrite our primary equation just in terms of x. And we can do that if we solve our secondary equation for y. So y should be equal to 108 minus x squared over 4x. So our primary equation becomes v equals x squared times y, which is 108 minus x squared over 4x, or we can cancel one of these out and get x times 108 minus x squared over 4. Now in our next step, what we're going to do is maximize the volume. So here is our function. We're looking for the maximum value. So first we need to find some critical numbers. So to find the critical numbers, we need to take the derivative. So I feel like rewriting this function a little bit to make it easier to find the derivative. So that's 108x minus x cubed over 4, which is just 27 minus, that's a 7, minus 1/4. Okay, this is not right. Let's try that again. 108 divided by 4 is 27. We still have this x minus 1/4 x cubed. Okay, critical numbers. So v prime is 27 minus 3 over 4 x squared. So we'll set that equal to 0. We get 3/4 x squared plus 27 equals 0. So x squared is equal to positive 36. So x is plus or minus 6, except we're talking about a dimension for x, so it should be positive. So we're only using x equals 6. Now from here we have a choice between using the first derivative test with x equals 6 or the second derivative test. This is kind of a nice polynomial, so I feel like using the second derivative test, but we should come to the same conclusion. So the second derivative would be negative 3 over 2 x. The second derivative when x is equal to 6 is negative 9, which is negative. So we can say that since v prime of 6 is equal to 0 and v double prime of 6 is negative, that v of 6 should be is the maximum value. Now the question asked us to find the dimensions that would give us a maximum value. And if you remember, we had an x and a y. So we know that x should be equal to 6, but we have that secondary equation solved for y. We know that y is equal to 108 minus x squared over 4x. So 108 minus 6 squared so that should be, oops, that's not what I mean. This is 72 over 24, which is equal to 3. So the dimensions that will produce a maximum value are 6 by 6 by 3 inches. So each problem is going to look a little different, but they essentially have the same set of steps. First, you need to write your primary equation. Now, if your primary equation is in more than one variable, then you'll need a secondary equation. Sometimes you don't need the secondary equation. You use your secondary equation to rewrite your primary equation in a single variable. Once you have that, it's just looking for your max or min, just like we were doing with curve sketching. So you take the derivative of your primary equation, you locate your critical numbers, and you have a choice between using the first or the second derivative test. After that, since it is a word problem, you write out your conclusion using complete sentences.